Mastering Smart Grid. Unlocking operational excellence demands identifying the KPIs that fuel smart grid performance. Where can we identify the critical key performance indicators, KPIs, that will allow us to measure and achieve operational excellence in our smart grid network, ensuring its optimal performance, reliability, and efficiency? The pursuit of operational excellence in a smart grid network, a daunting task, indeed. As I delved into this complex problem, I couldn't help but think of the words of wisdom from my esteemed colleague, Kurt Lewin. There is nothing so practical as a good theory. In this case, the theory I had in mind was my own hierarchy of needs, a framework that has guided my approach to problem solving for many years. As I began to tackle this challenge, I felt a sense of trepidation, much like a mountaineer gazing up at a towering peak. The task at hand was to identify the critical key performance indicators, KPIs, that would unlock the secrets of operational excellence in our smart grid network. But where to start? I took a step back, figuratively speaking, and asked myself, what are the fundamental needs of a smart grid network? The answer, much like the base of my hierarchy of needs, was rather straightforward: safety and security. The grid needs to be reliable, and its reliability is contingent upon a multitude of factors, including the physical infrastructure, data management, and human capital. With this foundation in place, I began to build upon it, layer by layer, much like the ascending levels of my hierarchy. The next need, akin to love and belonging, was the need for integration and coordination. The various components of the grid, from generation to distribution, need to communicate seamlessly, sharing data and resources in harmony. As I ascended further, I encountered the need for self-esteem, or in this case, efficiency and optimization. A well-oiled machine, the smart grid network should strive to minimize energy losses, reduce congestion, and maximize the use of renewable energy sources. Finally, at the pinnacle of my hierarchy, I arrived at the need for self-actualization, or in this context, innovation and adaptability. A truly operational excellence-driven smart grid network should be agile, responsive, and proactive, embracing cutting-edge technologies and adapting to the ever-changing landscape of energy production and consumption. Throughout this journey, I felt a sense of awe at the complexity of the problem, yet a sense of empowerment in breaking it down into manageable, hierarchical components. The KPIs, those elusive metrics, began to reveal themselves as I descended from the mountaintop of self-actualization, passing through the realms of efficiency, coordination, and safety. Some of the KPIs that emerged as crucial include mean time between failures, MTBF, and mean time to repair, MTTR, to ensure reliability and quick recovery from outages. Real-time monitoring and predictive analytics to anticipate and prevent grid disturbances. Energy efficiency metrics, such as power loss ratio and line loss reduction, to optimize energy transmission and distribution. Data integration and standardization to facilitate seamless communication across the grid. Cybersecurity incident response and compliance with regulations to ensure the integrity of the grid. Employee training and development programs to foster a culture of innovation and continuous improvement. As I concluded my ascent, I felt a sense of accomplishment, not unlike the feeling of reaching the summit of a mighty peak. The pursuit of operational excellence in a smart grid network is a daunting task. Indeed, but by applying the principles of my hierarchy of needs, the path forward becomes clearer, and the journey more manageable. In the words of my dear friend, Albert Einstein, the important thing is not to stop questioning. Curiosity has its own reason for existence. As we strive for operational excellence in our smart grid network, let us remain curious, let us question, and let us continually seek to improve, for the sake of a brighter, more sustainable future. To achieve operational excellence in a smart grid network, it is essential to identify and track critical key performance indicators, KPIs, that measure its performance, reliability, and efficiency. These KPIs will serve as the foundation for optimizing the network's operations, ensuring that it runs at optimal levels, and providing reliable and efficient services to customers. Grid reliability and availability KPI-Z. 1. System Average Interruption Duration Index. SAIDI measures the average duration of power interruptions per customer. Target: less than 60 minutes/year. 2. System Average Interruption Frequency Index SAIFI calculates the average number of interruptions per customer. Target: less than 1.5 interruptions/year. 3. Momentary Average Interruption Frequency Index MAIFI tracks the average number of momentary interruptions, less than 5 minutes, per customer. Target: less than 10 momentary interruptions/year. Grid Performance and Efficiency KPI-Z. 1. Power Loss Percentage calculates the percentage of power lost during transmission and distribution. Target: less than 5%. 2. Energy Efficiency measures the ratio of generated power to consumed power. Target: greater than 90%. 3. Transformer Load Factor monitors the percentage of transformer capacity being utilized. Target: greater than 80%. Operational Efficiency and Productivity KPI-Z. 1. Mean Time to Repair MTTR tracks the average time taken to repair a fault. Target: less than 2 hours. 2. Mean Time Between Failures MTBF calculates the average time between failures. Target: greater than 1,000 hours. 3. Overtime Rate monitors the percentage of overtime hours worked by field crews. Target: less than 10%. Customer Satisfaction and Experience KPI-Z. 1. Customer Satisfaction Index CSI measures customer satisfaction with power quality and reliability. Target: greater than 90%. 2. Outage Response Time tracks the average time taken to respond to customer outage reports. Target: less than 30 minutes. 3. Billing Accuracy calculates the percentage of accurate bills sent to customers. Target: greater than 99%. Data Management and Analytics KPI-Z. 1. Data Quality Index tracks the accuracy and completeness of grid data. Target: greater than 95%. 2. Predictive Analytics Model Accuracy measures the accuracy of predictive models used for grid optimization. Target: greater than 90%. 3. Real-Time Data Ingestion Rate monitors the percentage of real-time data ingested into analytics platforms. Target: greater than 95%. Cybersecurity and Compliance KPI-Z. 1. Number of Security Incidents tracks the number of cybersecurity incidents per quarter. Target: less than 2 incidents. 2. Compliance Rate with Industry Standards measures the percentage of compliance with industry standards and regulations. Target: greater than 99%. 3. Employee Cybersecurity Awareness calculates the percentage of employees trained in cybersecurity best practices. Target: greater than 90%. By tracking and analyzing these KPIs, utilities can identify areas for improvement, optimize their smart grid network, and achieve operational excellence. This will lead to increased customer satisfaction, improved reliability, and reduced operational costs.